So I will be solving maximum stone removal on weeks of weeks. The idea is that you are given a bunch of coordinates of stones, a bunch of coordinates in a 2D array, and the idea is that all of these individual coordinates are stones. So like every coordinate here has a stone in a grid, n by n grid, I suppose. I think it's a n by n grid. We have to find what is it that we have to find? The maximum possible numbers of stone that we can remove. A stone can be removed if it shares either the same row or the same column as another stone that has not been removed. Each coordinate point may have at most one stone. So in a n by n grid, you will have either nothing or stones. And those stones are determined by the positions or the coordinates in this stones to be added. The idea is to use a disjoint set since this is a dynamically changing graph, dynamic graph. What we can do is that we can take each row, so every single row, and connect all the columns that have a stone with them and are in that same row. Basically, take all the stones that are in a particular row and connect the columns of those rows of those stones into the row that they are present in. That can help us make a graph, a disjoint graph or a disjoint set that we can later use the union by the size function or the size of that particular graph to figure out the total number of components that are present inside a particular component, and then we can find the maximum stones that can be removed. The idea is that if there are four stones in a in a single component, we can remove at max 4 minus 1 stones because we need one stone that has to reach all the surrounding nodes or all the nodes inside that component. So that we are assuming that to the parent node. Assume. Just assume that. I hope I don't get a call right now. Is it so? Or maybe because of the extension that I'm using. So I already have pasted the disjoint class. It's a template that you can type and keep somewhere, and you can just copy and paste it every time you need it because there's no point in rewriting the class every single time. So let's start with getting the total number of rows, like the length of the graph, size of the graph. Then we need the maximum row and the maximum column. So what is the number that is the maximum that we need? I need a for in add a row in stones. N row is equal to the max row is equal to whatever is the maximum between the current one to the current maximum row and whatever is the row of zero. And the maximum column is the maximum between the current column and the first index at the row. Now I need my disjoint set. Ds is equal to new disjoint set of size max 0 plus maximum columns plus 1. I need a set of integer integers which will store all the columns and rows. So like nodes, for example, a new hash set. Hmm. Just can store it and then we can iterate in for int iterator inside nodes and we can do some stuff. Int answer is equal to 0. And over here I need For int row again inside stones or other stone inside stones, I need to get the current row, which is stone or 0, and then I need to get the current column. So now the thing is that every single index inside a disjoint set is unique. So when I'm creating a disjoint set, I create these arrays to pre-compute the desired result that I want. The rank of a particular component or the parent, the ultimate parent of a particular component or the size of that component. Everything is based on the indexes. But the thing is that, and these indexes are unique, obviously. The thing is that here, as you can see, the rows and the columns of a particular cell can be the same. I can have a 0, comma 0, I can have a 2, comma 2. So what happens is we cannot store separate, we cannot store two separate things, or like we cannot store a pair inside the disjoint set. We need unique values. For the column, what we are going to do is that we are going to find whatever is the maximum number of rows and then continue from that. So if the maximum number of rows in this case, in this example, is 2, the columns are going to be 2 plus 1, 2 plus 2, and 2 plus 3, respectively. The zeroth column is going to be 2 plus 1, the first column is going to be 2 plus 2, the third column is going to be 2 plus 3. So that gives us 0, 1, 2, 3, 4, 5. And um, it should be 6. 0, 1, 2. I know we are starting from 5. That makes sense. So we take the rows in the column that we are given. We add, what do we add? We add the maximum row that we have encountered and we add another one to make sure it stays that way. So the maximum row is 2 right now, right? For this over here, the maximum row, the bottom row is 2. So that would come here in the maximum row. Then whatever is the index of the column of this particular stone that I've gotten. So that is going to be 0. So 2 plus 0 and then another one that gives me 3. And my indexing that I'm want for my disjoint set is valid now. So I get this. What I do is that I just go nodes.add. First thing first, I need to add the nodes that I'm visiting. Anything like row, and then I also have to add the column. Then I have to do ds dot union by size of this row and this column. We are saying that this should be the parent, hopefully. I think that's how the code is supposed to be. Because I take all the rows, then I matched into all the columns. That works. And then the set allows me to ensure that I have a record of all the nodes or all the indexes that I've visited. And then what I can do is that I can iterate. It's going to give me something. It's going to give me this. So what I'm going to do is that if the ultimate, so ds dot ultimate, find ultimate parent of this iterator is equal to this iterator, means we have found a component, a unique component. Answer plus plus. But now how do I decide A? So it's like n into n, not total. What are the total number of stones? Hmm. Now I'm a bit confused. What are the total number of stones I can remove? So the total number of stones is the unique components that I have found. These are the unique components that I have k unique components. And from each component, I can remove. Okay, don't make this k like components. Make this components. You increase the components, any integers, find the components, and what I do is that int answer is equal to 0. Say that, or well, I can do this as well. I can just take this as answer. Fix some stuff. Say, okay, you increase the components and then you add answer with ds dot size of this iterator. The wrong brackets. I get the number of components in this, number of individual nodes inside this component. And then I can just return whatever is the answer minus the components. This should work. Compilation error, cannot find simple logic. What? Hmm? Okay, answer minus components. Now that it's compo NENPS. New disjoint set, max dot max. Max column has not been initialized. Hmm. Does this not allow for an disjoint set? I didn't initialize this, that makes sense. It should have been 0. Now is the output correct? Case 1 compiled, expected, everything works. Wrong answer. It's 105. My output is 10 and it's giving me. Is it because I'm using a set? Get the maximum row, get the maximum. This works. I send two separate numbers. And I'm using a set so that ensures I'm not taking any duplicates. And I iterate inside loss, which is a set. I find the ultimate parent of each of the elements inside the node. And remove two nodes from here, two nodes from here. What did I do wrong? What did I do wrong? You get the column, you get the maximum. Get I only add the rows. No, this is also wrong. You said dot add, you add it in the node. You knew that. Maximum row, maximum row, zero maximum. Its total number of components is what? I got for input 10. Before after the correct answer is 5. Hmm. I think I'm adding all the which makes sense. But I only have to add. I know these are the ones that only have a stone on with them. You can directly add size. खाना खाने के टाइम आएगा वो 5 5 बजे 5 5:30. You only add the size. Oh, I see what did I do wrong. If that is simple, and then ds dot size of this iterator is greater than 1. Hmm. into n minus k. I mean, shit. That's so dumb. Why was it n minus k? Oh, because the maximum number of stones. Hmm. What was I calculating? I was calculating all the nodes in a component. Whatever the answer is, whatever is that, minus one. And then the size of this. Okay, that's good enough. I think that did not work. That did not. But why is this not working? Let's ask ChatGPT. Yeah, what am I calculating? I'm calculating all the nodes in a single component. Component, and then I subtract one to two parent. Doesn't sound wrong to me at all. Mm-hmm. I have to face my fear. Mm, it makes sense because there are only n nodes and there can be n like maximum row, maximum column plus one indices, and all of them would be the same. But this should catch it. Size of the component is 5, sure, but there are only 5 stones. Am I not ensuring that the size must be greater than 1 and since and there are always going to be more indexes. That makes sense. But there are four strings, there are 8 columns, 8 indexes for example. I'm a little confused. Anyways, I'm gonna